welcome to our video on the graph of the cosine function. So when f of x is the cosine of x, what does that look like? Well, in the last video we looked at the function of sine of x. We looked at the sine function and we graphed that. And what's so neat about these two functions is, as much as there is going on, when you graph them, really what's happening is you're just taking one and you're shifting it over on the x-axis. And now I remember when I was in I think it was middle school or I guess high school, I'm not sure. I always thought of these two functions as different things because at 0 they look different, and you'll see what I mean. But we already talked about that a little bit in the unit circle. Remember, at 0, what does cosine equal? Well, that equals 0, but sine equals 1. And that is different about them, but really, when you look at these graphs on a larger level, you'll see they're exactly the same, and it's just that one is shifted over to the right a little bit, or left, depending on your perspective. But anyway, to proceed, we're going to look at this in terms of radians, which means we're going to be using the notation of pi and pi over 2 and 2 pi, and just remember that with our unit circle, and we're looking at these trig functions, you could think of pi as equaling 180 degrees. And that might help you think about why that's happening. And 2 pi then is 360. So ordinarily, I guess, without any manipulation of these functions, you'll see a cycle every 2 pi, or every 360 degrees, just like we saw with our unit circle. So what happens here? Well, we're going to deal with different angles. Right, we'll call those theta, and we have 0, and then we have pi over 2, and then pi, and then 3 pi over 2, sorry, and then 2 pi. So that's our full rotation, and this goes back to our unit circle. We can even just take a peek at that real quick. So if I have my x and y axis, and I have a unit circle, well, and that's a terrible sketch, but we can work with that. Remember, we're starting at 0, and then we go to pi over 2, that's right here, that's 90 degrees. And then here's pi 180, 3 pi over 2, that is 270 degrees, we're rotating this way. And then we go for rotation to 2 pi. And that's 360 degrees. And in other videos we labeled these points and talked about what's going on here. But the unit circle has a radius of 1. So what happens is these points, we can just label them as 1, 0, 0, 1, going around, negative 1, 0, 0, negative 1, and then back to 1, 0. And the cosine, as we talked about in other videos, is just going to be equaling the x value of each of these coordinates. So that means if we plug in 0 for theta, or 2 pi, we're going to get x equals 1, and we can plug that into our table right here. So when theta is equal to 0, the cosine of theta is 1, and at 2 pi, cosine of theta is 1. At pi over 2, cosine is 0. At pi, cosine is negative 1. At 3 pi over 2, cosine is 0. And then the cycle will repeat. We go 1, 0, negative 1, 0. 1, 0, negative 1, 0, and so forth. So what does this look like in a graph? And then we'll compare it to the sine, and we'll look, it's the graph of the sine function, and we'll look for similarities. So let's draw my y-axis, and here is my x. Well, let me put my x-axis a little bit further up. So here's my x-axis, and what the y-axis represents here are the cosine of theta values. So these are our cosine of theta values. So basically what we get in this column. And the x-axis right here is our theta values, is what we are plugging in, right? These are our x values, it's our domain, and here's our range. So at 0, cosine of theta is 1. I'll put that point up there. At pi over 2, cosine of theta is 0. So that'll be pi over 2. At pi, right here, cosine of theta is negative 1. So here's negative 1. So that point goes right there. At 3 pi over 2, cosine is 0 again. Cosine of theta is 0. And then at 2 pi, cosine of theta is 1. So I'm going to try my best to sketch that. Okay, cool. And the sine of theta, let me just actually make this column right here. The sine of theta, what was that? Let's just compare these two. Well, at 0, sine of theta was 0, and that's the big difference, right? That's where they are definitely apart. And then the function looks different here, but we'll see, in fact, that they are identical in many ways. So when theta is pi over 2, what is the sine value? Well, then sine is 1. And then we went over to the last video, then sine is 0 at pi, sine of theta is 0 at pi, and then sine of 3 pi over 2, what is that? Well, that is -1. And then sine of 2 pi is 0 again. So let's just graph those values. We have 0 and then 1 and then 0, -1 and 0. And this is, I think, where I got a little confused. I saw these as different functions, and they do look different, right? This in this view right here. But let's look at some of the similarities. First of all, they never go above 1, and they never go below -1. So they're bound by 1 and -1, right? They're trapped in here. And if we extend these functions to the left, the sine function, right, what would it look like? And what would the cosine look like? Well, instead of me graphing this out, it's kind of a little sloppy. Let's look at this this right here, this plugin I have. This is the GCalc 3, pretty cool stuff. And right here, in the blue and green, I don't know if you can see these, you can see that in these two graphs we have cosine and sine, and look how identical they are. They're just shifted a little bit. So the green line right here, that's the sine value. That's the sine graph. Look at it go, right? And it repeats. 2 pi is about here, right? And so the function goes, and then here repeats again, and it'll keep going. And the cosine, here it is at 0, it's 1. It's in blue. And there it goes. Comes right back up, and it starts to repeat again, right at the same spot. So these two graphs are identical. And we're going to go over the tangent, I think, in the next video. Just explain that a little bit, but let me show you what it looks like right here. Now the tangent, we get some funky results. And see, there it is in purple. And it's just really the tangent is a ratio of sine to cosine. So these graphs are expressing those ratios. But anyway, we'll talk about that a little bit more in the next video.